Hey, what's up, everybody? One more time this week. This will be the last video I'll make for y'all for quite a while, I hope. We need to make sure that we get finished with everything. We got done with the basics of the rational root theorem earlier, really trying to figure out what numbers should I be using in a problem. But we didn't get quite as far as you need to get for the first couple problems on your homework. I'm going to do two example problems real quick, probably going to take about 7-8 minutes. If you feel like watching this video before you try your homework, it's a good idea. If you want to attack the homework, you're probably going to ask me some questions about how to do the first couple. Basically, the idea is that if you use I, you should also use negative I. If you have a square root of 7 is one answer, the negative square root of 7 is also going to work. Whenever we have radicals or imaginary numbers, both the positive and the negative version are going to work. Both of these two problems that we do today will end up with either a radical or an imaginary number. So I've got my page set up. I'm about to go ahead and think about the rational root theorem. What numbers should I be using? Looking down here at the end, I don't actually have a constant term this time. And so I'm thinking about that. How am I supposed to use the factors of the constant term if there is no constant term? Well, I noticed that everything in the problem has an x first. Before I do anything else, instead of using this 0 down here, I want to remember that a long time ago, I learned about a GCF. What the GCF does, it says if these all have something in common, I can take that out first and not have to deal with it. If I do that, now there is a constant. This is what I'm going to set up for my synthetic division. The numbers that I should possibly choose are only positive or -1, positive or -5. Those are some pretty good choices, and we'll be able to do some pretty good work because of those. Setting it up for synthetic division now. My critical value is either going to be +1, -1, +5, or -5. But remember, I need to use the coefficients from my problem. I don't need that x from the outside. All I need to do is look right here. And because I'm looking right there, I'm going to be using a 1, 0, 4, 0, -5. So then Jacob Lacey stands up in the back row if I'm picturing my classroom right now. He's like, but Mr. Somerville, and then he says something real stupid. Why are there zeros, Jacob? There are zeros because if you're walking down a staircase, you don't skip from the 4th step to the 2nd. Going down a staircase, you need every single step in there or else you're going to fall flat on your face. Of course, we're all going to love that and laugh. First number's coming down no matter what. My critical value that I'm going to choose this time, somebody asked me during class today, well, what numbers should I use for my critical value that are going to work most often? I say start negative and start small. I'm going to start with -1. If I do that, every time I go back into the synthetic division, I'm multiplying, and then I just add going down. Oh my God, Mr. Somerville, it turns into 0 at the end. Is that good? Yes, that is very good. We wanted it to turn into 0, but we're not done yet. Maybe, just maybe, it would be a good idea to check another number. But remember, you don't need to go back to the original problem where you started. You just need to start right here. My new critical value, I made the problem, so I know how it's going to turn out. Just go with it for right now. I'm going to use a 1. Could I have used the -1 again? Yes. But it wasn't going to work the second time around. I knew that when I created the problem. I plug in my 1. Bring down the first one, and now I'm multiplying going up. Adding straight down. Multiply to send it back up. Oh my God, Mr. Somerville, it worked again. Yes, it did. So I'm looking at the page. Shouts out to Naomi Jackson, by the way. PT Girls Basketball. What up? I see you over there too, Cameron. looking at this problem, I have a trinomial. I guess technically this time it's a binomial. But I have 3 terms before that 0. This is where I want to stop the synthetic division process. Last chapter, all we did was talk about trinomials that were quadratics. This is a quadratic that says x squared plus 5 equals 0. You can solve that. If you go to solve that, you should have x squared equals negative 5. Square rooting both sides, you get x equals positive or negative square root of negative 5. This is where your i's come back. X equals positive or negative I radical 5. Now let me throw this at you real quick. If I have a positive or a negative, that sounds like 2 answers to me. I also had 2 answers. One of them was 1, the other one was negative 1. And then I had a 5th answer that came in the very beginning of the problem. Let me show you where that came from. Boom, bam! X could have also been 0. You have x to the 5th, therefore you should end up with 5 answers. Whenever you have an I or a radical, because of that last step, it will always bring the plus or minus. There's 2 of them on your behalf. This problem, the original said x to the 5th plus 4x to the 3rd minus 5x. We could have written that out as x times x minus 1 times x plus 1. And then, because I'm feeling kind of adventurous, I could do something like x plus I radical 5 and x minus I radical 5. That would be the factored form for the original standard form polynomial that we started with. The rational root theorem told us where to start, which numbers were my critical numbers to plug into synthetic division, but the second part of the rational root theorem says if I have an I or a radical, I should have the positive and the negative. Time for our second example problem. Again, I created the problem so I know how it's going to turn out. Trust the process. You should be able to tell me without a shadow of a doubt the only numbers that are worth checking this time are positive or negative. 1, 2, 3, 4, 6, 8, 12, or 24. That sounds like a really long list, but again, we talked about it earlier today. We said start with the small ones first. If you start with the small numbers, the synthetic division part will take care of everything that you needed to do. Coefficients first. Critical number goes here. 1, 5, negative 2, negative 24. Answer line, am I going to end up with 0? Again, because I made up the problem, I know how it's going to end. I want to start off this process using a negative 4 this time. Hey, baby.
Hi.
Erica's home, everybody. I'm making a video for my class. They said hi. That's my babe. I love her. Using the synthetic division with a negative 4 this time. When you send it back into the synthetic division part, you need to multiply that times the negative 4. Adding straight down, multiplying times negative 4 to send it back up. Oh my God, Mr. Somerville, it worked again. Are you a wizard or something? No, I'm not a wizard, but I'm halfway decent at math. So, what am I supposed to do now? Well, I got my x minus 4. Or excuse me, I got my x is a negative 4 already. But again, this is a trinomial. And the trinomial's degree is 2. All you need to do is solve a problem that looks like x squared plus x minus 6. And then we'll be done. Can you solve that? Yeah, because it's going to say equals 0 at the end. Is this factorable? Yes, it is. The other numbers that we could have been using on here were x plus 3 and x minus 2. My synthetic division, two of the choices that I could have used in the synthetic division, what the p's and the q's told me from my rational root theorem is that I should have checked -3 and +2 along with my -4. All of those choices are in the list that we started off the problem with. The factored form of this original problem, x to the third power plus 5x squared minus 2x minus 24, could really be written as x plus 4, x plus 3, x minus 2. So the big thing right now, know where to start. Start with small numbers, start with negative numbers usually. They work out a lot better for us. And then the second part is looking back at that first problem we just did. If you end up with a radical or an imaginary number, use the positive and the negative version. Peace.